Everyone.
Hello.
Hello.
Hello. Okay, let me grab the agenda. We're all here for a breakout session on EPBS. Thank you everyone for joining. Um, yeah, I mean, I think at a high level, we generally want to just kind of think on the state of EPBS for people who haven't been following but would like to start. And then from there, kind of discuss the state of the research. There's like a couple different implementation efforts slash R&D efforts that have been ongoing. So it'd be good just to kind of touch base on those and yeah, just kind of see where things are. And then, I think what would be really nice is by the end of the call to kind of have a shared understanding of, are we ready to move into concrete implementations? If not, how can we get there? So, okay, maybe I'll give people one more minute because people are still streaming in, but then we'll kick things off. Okay, the people have stopped streaming into the room. So I was thinking to get started, I would just take even just like 5 minutes and kind of like explain what PBS is and like why we want to enshrine it and where all of that leads. I think I'll just probably pretty briefly follow these notes I left in this comment here. This one I just dropped in the chat. So, what is PBS? Well, proposer builder separation. And the idea is that validators, when they go to propose blocks, they somehow are producing block space. And then you have these other actors called builders who want to buy it from them. And so PBS, at least one way to think about it, is that you have this auction to facilitate this exchange. That being said, well, I mean, yeah, there's a lot of context here, but ultimately there's a current design that we leverage that kind of shipped around the merge with MetBoost. This is something probably all of you have heard of. And there's like an additional actor in the MetBoost picture, which is sort of an off-chain PBS called the relay. And the relay basically is there to like paper over some trust issues that we'll definitely get into in this call are between the proposer and the builder. So one way to think about it is that the relay is kind of like maintaining this auction or like, brokering it in some sense. The builder says, hey, I want to buy block space from the proposer, sort of with this payload. The relay needs to make sure the payload's valid. And then also when the proposer goes to like sort of sell the block space, that the payment actually goes through. So there's a few things that they do. However, there are these like single points of failure. And then, yeah, what I called out here in these notes, targets for implementation of censorship. So this is a big concern that we've had with how the relays are structured. Many of them are choosing to censor. And again, that's kind of a whole different conversation. But what it means is that we sort of have this core Ethereum value that's being harmed by this protocol actor. So this is something we'd hope to get rid of. There's also a question of funding the relays. And again, this is a whole nother different sort of side quest, but ultimately, it's not clear that the relay system is that sustainable in the long term. And so if we could get rid of them, all the better. So we have these relays, but really we want to get rid of them. And this is the idea now to like enshrine them somehow into the protocol. At like a high level, you could think of like rather than have builders and proposers go through this relay actor, you can imagine they use like peer-to-peer layer, some gossip infrastructure to coordinate. The protocol itself can enforce payment. And, this idea sounds nice. There's at this point been there's been much work over many years to kind of make a concrete specification as to like how this would actually work. You still have to do all these different types of things around like, is the payload valid? Is the payload available? If I go to like pay the proposer, like is the payment valid? And you have all these questions that come up. So to start answering them, there's like a series of designs. Yeah, just to start with the first one, is this payload valid and on time, right? So like when the builder goes to release the payload, you want to know that the thing they release again is valid. Otherwise, they could grieve proposers. You also want to know that it's timely. Otherwise, they kind of miss their opportunity to get into the chain, and that's not great either. So this takes us to what I would probably call the state of the art around this idea of PTC. PTC is a payload timeliness committee, and basically it's adding this extra protocol actor, or rather, I'll say it's adding an additional duty to attesters to attest to this payload release in ePBS. Does someone have a link handy to PTC design spec? Any documentation? If you do, could you drop it in the chat? But I think we'll be talking more about this soon. That being said, I think there's some issues with PTC, at least that I see. I think a big one is essentially coming down to like builder safety. So the way that this works is that now there's like the proof of stake fork choice involved with these committees, and there's different things validators could do around sort of splitting the view of the fork choice for each node to grief builders, and that's not great. The reason it's not great is if builders don't use this thing, then like what's the point? There's all this complexity in the protocol, and that's just not good. But again, I think we'll get into some of the details there in a bit. Another one, essentially, like if we do move from today's world with Node Boost, where honestly there's like these very optimized point-to-point networks, sort of over more conventional, like for example, HTTP APIs. If we move to more of like a peer-to-peer gossip style, there's probably just going to be higher latency than we see today. This is a problem because all these MEV systems are like incredibly latency sensitive. It comes down to like even shaving off like milliseconds or more is profitable for someone, so people are investing to do so. And if we present them a system that is sort of less precise on latency basis, then that's just not going to work. At least that's what I think. There's other questions around payment. So basically, when a builder goes to actually make one of these blocks in ePBS, you have essentially, the builder needs to pay the proposer. And the concern there is like, how do they actually do this? One option is basically when I go to pay the proposer, I kind of do it just in time. And when we think about this with like what we have today, this kind of means they have to attach a transaction at the very top of the block, which is fine. But it does kind of mean the builder has to have that capital up front, which again could be problematic for some types of MEV that we see. Otherwise, you can imagine they have this, some collateral locked somewhere, the beacon chain probably. And then from there, they sort of pay out of that with each block. So either way, maybe I'm getting a bit into the weeds here, but ultimately the point here is just to point out that there's a huge design space, and we are here today to discuss. Yeah, Danny?
Yeah, when I've been a part of like smaller, large group versions of trying to align on ePBS before, it's really some of these questions and other things that like, it's not even clear what the right optimization path is. And I think that's why we often get stuck. So either now or maybe after the call or later in the call, it's just like, what are the features? Like, what are the features we need here, right? And like, certain things come up and it's like actually unclear what the feature is or to the extent we need it. For example, like, quote, builder safety, what is builder safety? Meaning like once they've done something, the chances their action makes it on chain, and can they be griefed or can they price it in, or there's all sorts of these things where it's not, I don't know, often these conversations get into the point where like there's a lot of fundamental disagreement around these core features. So at some point, maybe post call, we kind of see where we're all at. Maybe it's worth kind of trying to like specify those a bit more clearly. For example, it's like, does everyone need to use this, or does this need to be as good as relays, or does this need to be like within some delta as good as relays? And what is that? What is that delta? Anyway.
Right.
Funding
I
is,
mean, I
it's like
would
not
say
even
that
just some of
that
these questions. It's like, what are we even attempting
yeah,
to do as becomes hard in these conversations.
sure. Yeah, definitely. Um, maybe to kick us off there, then, like I would say that we want something that everyone's using. Like to me, it seems not great to add all this complexity to the protocol if ultimately it's just this like rubber stamp and we don't actually solve any of these like quote off-chain issues.
I do, well, I even question that. Like it's not even clear to me. Like actually, if it's the protocol is the relay of last resort, maybe that then provides a healthy market and sustainability and stuff on top of it, because it's not ultimately people only going to use a relay at that point if it's additionally profitable, and at that point then relays potentially charge, and all of a sudden maybe you have like a valuable market. Whereas like if you don't have the protocol is not a relay last resort, then maybe the market dynamic is totally different. So like I even question that. But I'll leave it there. I know there's a lot of things to get to.
Yeah. So maybe before we just jump into the weeds, does anyone have any questions? Like, I'm not sure how much we want to like, kind of quote cover the basics versus um we could just get into things. Okay. I'll assume that everything I said makes sense and we're all on the same page, at least with respect to the design space. Yeah. So I mean, maybe I'll take suggestions. From here, I was kind of thinking, so I know that POTUS is here and he's been doing a lot of work on sort of a flavor of PTC. One option would be to POTUS. I don't know if you want to say something about what you've been working. I think Terrence has been also working on that, although I don't see him. Oh, there he is. Yeah. So I don't know if you guys would like to say something about what you've been working on, or maybe even just like start with like, you know, yeah, sort of like along with Danny's lines, like what design principles are you thinking about and how are you approaching the problem?
All right. So yeah, I agree with Danny. I think we first need to agree on what is ePBS versus what is PBS, and what's the purpose of it, and what are the constraints that we want in the problem. And I was guided by some design choices and some dichotomies that I posted on Neat Research a while ago, which led me to think that of this notion that builders, the attesters for the payload should not have any for choice weight. This in itself gave rise to this attack, which you mentioned at the beginning, which is this balancing attack. You mentioned 3 points that you sort of like see as weak of this design. I can describe the design in detail in a bit. I'll add one extra point, which I think is very weak on the design, which is, so you mentioned the 3 of them, balancing attack. Then the second one is about like P2P gossip style and the non-adherence of builders if instead of like opening an HTTP point.
Right.
And the third one is the way that payments are going to be handled, if it's just on time on the execution layer, or if it's staked and they need to have the balance up front. I'll add one extra more, which I think is the most impactful actually for the protocol, which is protocol complexity, including changing the slot time, which I think is something that is just immediately a non-starter if we change the slot duration. So I think that's another
From an
one.
engineering standpoint or like a social standpoint?
Yeah, so complexity at the level of engineering is in general is a problem, and within complexity, the highest would be changing the slot time.
Okay, and when we say slot time, we mean like this whole round of whatever's happening, like the
Right. So
negotiation.
the whole
Yeah,
round
okay.
is currently at 12 seconds. I think we can keep it. But the sign that I have open as a PR has it at 16 seconds, just with the desire of keeping the attestation deadline at 4, but we can actually make it 3. But let's not get into these technical
Okay,
things
okay, thank you.
right now. What I would want is to argue against 2 and 3. I think those are just non-complaints. These are just not an issue. And I would want to mention what is this balancing attack, which is a problem that this 4 choice, we don't have a solution for this. And what I would like is that after a few of these meetings, we either agree that this is a problem that we need to think and solve, or we just agree that, well, we should shelve this and try to think from scratch on a different design. My point of view here is that there is one attack to this, which is builder safety, and this is balancing attack, and we need to find a solution to this. And I would hope that we can just sit down and think of way of solving that problem. So I don't know how you want me to go, Alex. I can just describe what is the way that PTC is, how is that we're implementing it, how is that we're specifying. I could describe what the 4 choice changes are, and what is this balancing attack in detail. Or I can argue against 2 and 3 of your complaints.
Yeah.
I'm
And to be
happy to
clear,
go
I'm
either.
not trying to like block anything. It was more just to kick off the conversation. But yeah, so I think whatever you think makes sense. Like probably what would be helpful is like maybe you could touch on the high level features. Like again, for example, we've brought up this issue of builders being staked or not. Like how does that come in?
Okay, I can describe what is the feature. So what is the weakness that this would generate for builders? This is a property that builders have today. A builder, if it reveals a block, if it reveals a payload, and on time, honest validators see this payload on time, then that block is canonical. It's automatically canonical. And this is a feature that it seems that EPBS, in the flavor that we have it now, would be lost. This is the reason why all of these designs for EPBS go in 2 rounds of voting. A proposer gathers the header just as we do now with MapBoost, for whatever means. It can be on the P2P network. It can be just directly requesting from the builder on an HTTP endpoint. You just get a header and you submit your consensus block with a commitment to include a payload from a builder. Attesters attest to this block or not. If they've seen it on time, they attest. If they haven't seen it on time, they attest for the parent block, just as we do now. Some point into the slot, the builder that has been counting attestations, if the builder sees this block on time with a commitment to his payload, and it sees, like, say, like 100% of the committee has voted for this payload, then he will reveal his payload, broadcast his payload, fulfilling the promise. If the builder sees 0 attestations for the block or doesn't even see the block, then the builder will not reveal the payload, and just that because it doesn't need to fulfill. Now, there's another committee that just attests for the presence of the payload. So right after the full round of voting happened, attesters for the next block, or the 4 choice runners for the next block, yes, they do attest for the validity. There's another discussion on that. Mihail says that they don't need to, but I think it's impossible to do that without breaking sync. The point is that right after the end of the slot, validators have gathered votes for both rounds, and they know what their head is. And with respect to the current slot, there are 3 possible options. No block was included, so no consensus block and no payload was included. This is just like a missed slot today. The full block was included, namely the block appeared and the payload was revealed, fulfilling the promise. That's just like a present block today. And there's a new entity that should be considered in 4 choice, which is an empty consensus block. I will call those empty blocks instead of skipped. This is where the consensus block has appeared. It was voted. It is the canonical head, but the payload was not on time or was not there. So now the problem happens where there are 2 forms of grieving the builder, some new figures that appears, which is the following, which is the block is revealed by the proposer with a commitment to a payload, but the proposer either times it on purpose or happens by chance, sends it slightly late, and a percentage of the committee sees the block on time and a certain percentage of the committee does not see it on time. In this situation, the builder that has been gathering these attestations doesn't really know what to do. And it lost the assurances that he had before EPBS. The problems are as follows. If the builder sees a weak block, but not so weak, and weak here for the current values of proposer boost means if he sees more than 30% and below 70% of the committee has voted for the block. Under these circumstances, the next proposer can choose to build the block based on the parent block or build the block based on the current block that is being proposed. And the next proposer, because of proposer boost, would actually make it both ways. He can reorder the block if it's not highly voted, and he can build on top of the block if he had enough votes. Those numbers are 30 and 70 if I didn't get them wrong. So the problem here is that if the builder decided not to submit this block because he saw only 35% of the committee voting, and then he says, no, I'm not going to reveal the information that I have. I'm not going to reveal my payload. Then the next proposer can greet him by building his block on top of the consensus block. And then the builder, because of what EPBS is designed for, will be forced to pay the bid, even though his payload was not included. The opposite also happens if the builder decides to reveal his block and the block did not get enough votes, so for example, less than 70%, then the next proposer would be able to reorg it. And if the next proposer is able to reorg it, then he can't really do this unbundling attack, which is reuse the transactions on the same slot, because typically searchers would protect themselves. The transactions will be executed in a different slot, but he can use the information that the builder revealed. So this is what I consider is the problem of this design. I can argue against the other ones, besides slot time that I think we can fix, but this problem needs to be fixed, and I would want to talk possible solutions eventually, probably not today.
Gotcha. Yeah, thanks. That was a really great walkthrough. Yeah, so zooming out, this is ultimately this notion of builder safety we keep circling around. And I guess, yeah, this is a conversation worth having, is to what extent, do we think these issues are relevant? Do we care? I think I saw you trying to get some input from more networking specialists in our community. Did that go anywhere? Because this would be something here, is to what extent, how easy is it actually to split views like we're talking about?
So this is a view split that a proposer at slot n induces or is attacked by, because the proposer at slot n can probably pretty accurate.
It's one they induce, they're trying to split
okay. You have to assume that it's feasible. You have to assume that the adversary is directly appeared to everyone and has de-anonymized them and is hand delivering payloads. In the practicalities, it might be quote hard, but I think an adversary who's willing to do the legwork can split views. And the protocol has to be designed in such a way that you assume it. Whether you assume it and they do it and maybe the outcome isn't that bad, that's one thing, but you have to assume that they can do it. Protest.
Yeah, so one feature here is that it's not only that they need to split the view, but they need to split the view along prescribed splittings. Namely, if you fix proposer boost, then you need to know exactly the percentage of what is the next committee that's going to see it. And I think this can be gained. So I just posted something on RNG, so that it's just the first idea. The thing is that this is a problem that we might be able to solve. one idea would be to not have a deterministic proposer boost that is it's only known after the builder has revealed his payload or not. And then in that way, the proposer of slot n cannot gain the split, the splitting, because he doesn't really know what is the percentage that needs to be split.
But is it a random distribution? Because if it's a random distribution, then they can model it, right?
No, well, even if you do it like a random, which the builder might influence it because he will know it before anyone else, and he could just choose to reveal or not because of knowing this. Even if you model it, as long as you have like enough of an error bar, this attack does not become possible. Does not become lucrative.
Well, it depends on the value of these and whether they're doing a repeated game. If they can model it and there's an error bar, then if they play it, 100 times and there's certain delta on it, then it can be profitable. In the single game, then it's probably too risky. But I do worry about these random distributions and whether that they actually protect us in like a repeated game.
Right, but even then, you may not make it random by say like the distribution is going to be modeled by a hash on the extra data of the builder, and then it's not random. The builder is just going to adjust, and it's one way of allowing the builder to actually set proposer boost, and without really giving it fork choice weight, because the builder cannot choose between two different forks. He can only like help or not boost the next proposer if it's being honest, building on top of his own head.
Can you explain that? How does the builder choose how much boost they give the next one?
Yes. So let's say, so there's two issues here. One is that proposer boost on ePBS probably needs to be gone or lowered a lot, because we model proposer boost based on ex-ante reorgs and post-ante reorgs without block slot voting. But on ePBS, block slot voting is sort of like a must, because you need to be able to penalize the proposer not posting a block. So so that's one comment. And another comment is this thing
that comes with other problems for the fork choice rule. Like the proposer boost is there for a reason. It's like to prevent certain long-term attacks on the fork choice rule. So we would then improve those attacks.
Yes, that's correct. So we need to. So the thing is, I was reading the chat also. Francesco saying box slot voting certainly has a problem. And fork choice becomes actually much more complicated than we are discussing here. There are some issues like if a vote for slot n, how do you propagate it along the chain that is supporting that block in slot n? And there's some subtleties there. We can look at what I'm proposing later. One of the issues, for example, is if you voted for a block and the proposer of a child does this block, can be basing his block on top of like full or empty. These are two different things. Do we count any vote for slot n along the chain or not? So these subtleties change fork choice quite a bit, and the whole thing of proposer boost needs to be studied for reorgs under this new voting system. But besides all of this, even if we manage to like model all of the proposer boost, what I'm saying is that the builder has one option. Besides just giving the attesters of this committee fork choice weight, which is something we didn't want to do, that's why PTC, what we can do is the builder adjust proposer boost by essentially just saying this is how much proposer boost would be, is going to be among these prescribed values. One way would be like the hash of extra data or whatever it is.
I mean, like, as a builder, proposer boost is always a risk for me, right? So I want to always set it as low as possible.
And that might be the case. That might be fine. So
I feel like I would just, as a builder, I would just grind that extra data to have as low a proposer boost as possible always. So I don't see how that adds anything. Well, but then you might just we might as well forget about that thing and simply say proposer boost is always the minimum.
Yeah, so with block slot, actually proposer boost at 0, you need 50% to build on top. So to do a post-ante reorg. That's a 0. And ex ante reorgs, which is the one that I don't remember actually the numbers for with block for ex ante reorgs. Probably here has them fresh. But even at 0, so
even 0 proposer boost doesn't completely solve our problem, because you can also use a testers to reorg. Like I can balance, and we don't know, like this would be one thing that would be interesting research to do on how difficult it is right now to balance committees to within 5%, 1%, and so on. Because my intuition is that it's actually not difficult. My intuition that balancing to within 1% is not hard if you like try hard enough. Like if you collect enough statistics, know exactly where you're going to release those blocks, I think you can potentially balance committees to within 1%.
So you
and
think
if you can do that, then
so
you
this
just
is on the
need
network, right? So you're saying that you can decide up to 1% of error when you release your block, what's the voting is going to be. And I'd be happy if we actually get these measurements down. Whenever I talk to researchers, they tell me, yes, this is possible, this is easy. And whenever I talk to people that work on P2P, they tell me it's impossible.
It's not a trivial research. I mean, it's a big research project, because like you actually have to invest the time at like trying this. It's probably like, because like there are many different methods to try to balance this, right? Is it enough to simply release your block in the traditional way at the boundary and figure out the best boundary? Probably not. You probably need like to have like at least hundreds of nodes, know like get some statistics on which nodes have how many validators and so on. But then, is it possible? I mean, I'm just saying I would not be surprised.
I think that there's a pretty interesting research project, and I think that you start with the assumption that you know the validators on each node, because that is certainly doable with the way that P2P works today. And then you run simulations from there and strategies from there. I can see if I can find somebody that wants to do this.
Yeah, I mean, this is not going to be an easy research project. This is going to be at least months of work, and
yeah. This isn't a like a weekend project. Well, maybe for somebody, but no.
I mean, if you're very lucky, it might be a weekend project because you find a very easy way of doing it. But most likely, it's a longer term research project. Then
the simulation
we
is
don't
appropriate.
Know. We don't know. I mean, ideally, you want to assume the worst case, right? That it's fairly possible to get this within relatively tight bounds.
Yeah, I mean, it is the default assumption that you kind of in traditional academia that you take, that you can deliver these types of messages with these timing constraints. You know, we're certainly deviating from like the assumed adversary in traditional literature if we say no, we don't think so. But that is definitely the like traditional assumed adversary on the P2P, and you can easily imagine why it is, even if it's hard. And hard, I think, becomes a dollar amount, not a I think hard becomes a dollar amount, like on the order of something not to the level of Ethereum's crypto economic security, you know, a validator set size. But I'll put out some feelers and see if anybody wants to take it on.
So I have a proposal, which is, I mean, I'm certainly not denying that this attack is there, and I think this is the biggest problem of this design. My hope is that we can actually solve it, that we can think of ways of solving this problem. But perhaps let's agree that there's this problem there. We can or not discuss whether or not this problem is a theorem. We cannot solve this problem and then we just trash everything. Or we can try to move forward and try to solve it eventually. We can argue about the other points. But it's clear that there's an issue here. My hope is that we can actually fix it instead of like trashing the whole project.
I think nobody is suggesting trashing the whole project. I think we all want to find better designs that have as few of these problems as possible.
We could,
and I think the point here is like, go on.
Go ahead, Danny.
Yeah, but I think aligning on like what is the threshold of agreement on these different things, that it becomes like we can move forward. And I do think there's some disagreement across here.
If we say that we solved this builder safety problem, like we could kind of start there and then say, do we want to do EPBS given we have builder safety? Like a builder, like let's say we have the same builder safety as MEV boost today, then I guess that could kind of be a way to transition into the next part of the discussion, which is more about protocol complexity, slot times. I think some of the, I guess the second round of issues that Potas was talking about earlier, which is, yeah, slot time mainly, I guess.
Is there a reason why we are not at all talking about Vitalik's design, where both the proposer and the builder get a boost?
Can you explain that? And then I think there's probably some rebuttal.
Well, to me, it's been a long time since I looked at these things, but it feels like it's very similar to the PTC, except it's like basically in both cases you have two blocks with two committees. But like in Vitalik's design, it was much more symmetrical, and we basically just had a committee for both of them, and both the builder and the proposer get a boost, and in particular the builder boost stops the builder from getting reorged, because the builder can basically, if they within a certain range, they can decide whether to release or not. Like if they see, say, between 30 and 100% of the votes, they can use their own boost to like get over 50% and get guaranteed that all attesters, like all honest attesters, are voting for that block. And therefore it's solidified and can't be reorged by the next block anymore. And I think like the main problem we had was that people said, well, now we have, because like proposers can select themselves as builders, so effectively you get the proposer boost twice. My intuition is that this just means you should have the proposer boost, but I don't know like if that's exactly correct. But and clearly that does weaken the fork choice rule, but like, I mean, also in this case, we also have to like decrease the proposer boost to reduce the risk for the builder. So I'm not sure if it's that bad, or at least I feel like it's still better than the PTC design.
So one thing about this design is that in order to actually, for proposer boost, the builder proposer boost to be effective, you really need, I think, a full committee to be attesting to the builder part, so that it kind of solidifies whatever the builder proposer boost has kind of nudged people towards. And so it really becomes more of a 2-slot thing rather than like this, still trying to keep it 1 slot by having the PTC committee being small and non-aggregation. So I guess that's one thing that it does, it kind of increase the complexity and the cost just by increasing slot time, the effective slot time essentially. And then, but the other thing that I mean, you already kind of said it, but yeah, the issue of having this double boost is that basically in the current consensus protocol, the security arguments against long-term balancing attack and like this kind of yeah, I mean, essentially all these ways to try to prevent liveness basically rely on there being a certain percentage of honest proposers. And yeah, essentially it's, if we give boost to builders, you can basically count half of the actors as being dishonest, essentially, potentially. Like, I think that's the right thing to do, to just treat every builder as being malicious. And yeah, it just makes that kind of attack much worse. Now, I don't know if there is simple ways to mitigate this. It didn't seem clear to me that that can be done. But yeah, just if you literally just do this 2-slot thing and do not change anything about how things work, just give proposer boost to builders, for sure it makes all these attacks much worse.
Right, because you're saying even for honest proposers, like the attacker would simply outbid the highest bidding builder to also get proposer boosts for those slots.
Yeah, exactly. Yeah, like basically, I guess the worst case is like, let's say that there is a dominant builder that doesn't even need to spend money because they're winning blocks already, and they happen to be malicious and want to just create chaos. Then yeah, it's basically becomes equivalent to just half of the slots being given to malicious proposers.
Right. I see.
Otis, you had your hand raised.
Yeah, so, but I was essentially to say the same thing as Francesco. I would add as a constraint. So we have builder safety as a design constraint for the system. Another one, I think it should be keeping slot time, because it's really hard, close to impossible to change this on the engineer level. And I think that but this is just a belief. I think that keeping slot time is impossible if you have 2 rounds that need to be aggregated. So if you are going to add a second voting that needs to be aggregated, I think it's impossible with just keeping the slot time that way. So that forces us to have a small committee for the second time. Having said so, I'm not against boosting the second committee if it's even possible, it being small. We can play like the theory, we can do some simulations to see if there are numbers that are reasonable. Originally, one of the reasons we didn't want to have boost the small committee or give any for choice weight for builders is because we thought this would be a very constrained set of players that we didn't want them to be choosing between ports. So this goes to one of the things that Dankrad said, which is proposers can't select themselves as builders. In the design that I was working on, builders would be staked, payment would be carried on the CL side, and I can define that because of just code complexity. It's much simpler to deal with stake builders on protocol and just pay immediately on the CL as you process the header even of the block. And in this design, well, the proposers can't select themselves as builders.
Okay. So we have about 20 minutes left. I don't know if we want to dig into any of the other points. It seems like we at least agree this is one of the biggest blockers to the current PTC design. So certainly something to dig into deeper.
Something Mike mentioned is worth surfacing, just like self-building as that, being a requisite feature of EPBS or not, it being another component of the trade-off. Another, and like, I guess the nuance and often the rebuttal with it's not a prereq assumes then another feature, inclusionless, right? So still being able to maintain influence on the block without being able to build it, often is that optimization.
Yeah, by the way, we sort of like the reason our PR became too large is that we wanted to have like state builders so that self-building is not possible. Then that forced inclusion list on us. Then since this builders would be state, that forced max EB on us, and max EB itself requires 7,002 on us. So most of the PR, it's those 3 big changes.
Yeah. I mean, I see the dependency path.
Well, and so that kind of suggests maybe way forward is over the next like fork or two, we ship these prereqs, and then that gives us time to dig into this builder safety issue, and then there's a path ultimately.
Let's save that discussion for the EL meeting.
Sure. Just servicing it.
I wanted to mention quickly your point.
Well, actually,
points.
Sorry, 1 second. Is this call only until 8? Are there 15 minutes, or does it go past the hour?
I think it's scheduled for the hour.
Okay, great. It sounds like there will possibly be more of these. Okay, sorry, POTUS, you're saying.
Oh yeah, so I want to comment on your second point, which is this issue of like not using the system by like not using P2P gossip. I think this is a no-brainer. Like we will never be in a situation where the P2P network bits are going to be useful in any form. This can always be bypassed, and that I think is absolutely fine. This is not a requisite of EPBS. And I don't think this, I don't even see that this is a problem. I think of EPBS as a way of enshrining the relay, not enshrining the builder. And I think it's absolutely fine if we are in a place where the P2P gossip layer, it's only there as a as something that we will fall back if an aliveness situation where the standard builders are not live. Typically what would happen, what I envision that this would happen is that builders now will not even need to do the BNG. They can just become relayers immediately, and they just open an endpoint. They just open an HTTP endpoint, which they cannot do today because they are not trusted. But after EPBS, they can just open the endpoint, and we can just continue getting the headers exactly as we do today with MEV-Boost directly from the builder. I don't see any problems if this is the situation. Builders become relayers. They're just trustless relays. They're parts of the protocol. If builders are not state enough and they need to go to a separate, to have some sort of business with relays that are going to be the ones staked and signing the blocks for them, that's fine as well. This is just something that is happening between the builder and the relay, but the relay now becomes trustless, which is the objective that I think is the main objective of EPBS.
Yeah, I definitely like the mental model of like staked builders is more like enshrining relays than enshrining builders. I think that makes total sense to me. I guess the issue I have with the trustless relay framing is that we don't know that the full bid value will capture the payment like to a validator. So for example, if a validator is like listening both to the kind of the bid that's signed by the builder and is collateralized with whatever like automatic payment mechanism is there, the builder could also tell them that like we'll give you extra payments outside of the protocol in this way, and like they'll just take that higher bid if it's bigger than the trustless one. So I think if the builders use the protocol as designed, then it would be trustless, but we have no way to enforce the builders to use the protocol as designed. So that's my main issue with the trustless framing.
I don't understand how is it that builders are not going to use the protocol as designed?
Like, for example, let's say I'm a builder and I just sign I sign a bid to the proposer through the protocol mechanism. That's like 0.01 ETH. And then I tell them that I'll pay them like 0.99 ETH out of the protocol. And they just have to like trust me, bro, on that portion of the payment. Like if I'm a validator and I hear, that they're going to give me a 1 ETH bid fully, I can just trust them in that regard and like bypass the protocol there. And like the reason that this might be, well, I guess it just means that the protocol isn't being used. Like then I guess it doesn't feel like it just like if we're trying to get rid of trust between the builder and the proposer, it doesn't actually get rid of that trust. That's the issue.
It does. You're deciding to trust more. That's going to happen on any protocol. It doesn't matter what protocol it is. I mean, I can pay you for you to not propose a block 2 and just keep your block. And I can do this off chain. What's the problem with this?
Well, yeah, I guess it just doesn't make it a trustless relay, right? Like it's still trusted.
Yeah, I often see it as like providing a baseline trustless mechanism, and then the market can layer on top rather than having a zero mechanism that then we have an unsustainable market layer on top.
Which is absolutely fine.
Yeah,
I mean, you could argue we have that today, right? Like,
no, you don't.
Protocol
today you have to trust someone. You really have to trust someone. You cannot have someone
you can still
building a block for you.
It's a matter of what that delta is. Right now, that delta is huge between using the local mempool and the trusted market. And I see it as does EPBS provide a significant baseline such that delta is much smaller, such that then it becomes like a kind of a market choice rather than right now.
Sure.
I mean, I guess it would be interesting to see, like, for example, like right now, if we assume we can only trust EPBS up to 1 ETH blocks, like right now, what percentage of MEV comes from greater than 1 ETH blocks? Right, do we know that? I feel like the distribution is extremely skewed, and people have told me before that a lot of the MEV comes from very high MEV blocks. So then it does less. Yeah, and I don't know what exactly that is, how bad it is to put like, say, like as something like a 1 ETH separator in there. But that would be like an interesting thing that would tell us something about how valuable it really is.
And so maybe just to respond to POTUS a second ago, like this is, I think my point is if we add all this complexity to the protocol to like have this sort of relay of last resort, but it's used very infrequently, like was it worth it? And I think it's an open question, but that's kind of, I think, is really a key consideration here.
I don't understand, why would it be used not frequently if it's used constantly now? This, from the point of view of the validator, the UX doesn't change. You just request a header directly from the person that would send you the block, the payload. From the point of view of the builder, it becomes much better. He doesn't need to trust the relay anymore. He just opens his own HTTP endpoint. From the point of view of like the builder that doesn't have the money to stake, it becomes exactly the same as it is today. He just trusts another entity that would send the blocks for them. So I don't see why is this not an immediately no-brainer that it's going to be better in any situation.
I mean, for example, a builder might say, like, not a builder, but like the 2 or 3 builders that actually matter. They might just say, like, no, like this is too risky for me. I prefer the current situation. So if you want to get blocks from me, just keep doing it the way you're doing before. The in-protocol bid is going to be 0, and you just have to just
that's
keep using my
absolutely
boost.
fine too. We can open our own builder. I mean, if there's 0 builders that want to be part of this, the Prismatic team would be very happy of running our own builder. This is certainly a lucrative market.
But like, I mean, that's assuming the validators are gonna care about these extra guarantees, which like is not necessarily the case. I mean, it's, you know, are you like, there's not that much of a cost today in just trusting that a relay is actually going to give you their blocks.
Well, but the point is that you're not going to be able to do so because you're not going to be able to get a block of, you're not going to be able to even sign a block of, say,
well, a builder can just be staked and be part of the protocol, but just not, their bids are going to be 0, but they are staked and they are allowed to be a builder or a relay or whatever you want to call it. It's just that they don't communicate their actual bids to the protocol. So you're still using that boost, trusting a relay, etc. But the builder, yeah, sure, the builder,
that's fine. They don't need to communicate the bids. They don't even need to propagate the bids. They only need to open their own HTTP endpoint as they do today, and the proposer can request it exactly as they do today. And I don't see any problem with this. As long as the builder, some in-protocol object, some in-protocol entity signs the payload instead of someone that didn't produce the payload signs it, I think it's fine.
Okay, but the builder can just
the
say
signature
0 ETH.
Yeah.
Like the builder can just sign a bid that doesn't bid anything, and the actual bid is just an off-chain object. And just because they don't want to trust this mechanism to protect him, and they prefer the existing mechanism. I'm not saying this would be the case, but like it's literally up to like 2 or 3 builders whether or not this is actually used.
Oh, I think this is fine. So you're saying if the proposers decide to take blocks from builders that don't offer them any security and they have to be trusted, that I think is absolutely fine. Proposers may decide to trust someone. What I don't like is that proposers now are forced to trust someone if they want someone else to build their blocks. They don't have the option. They either build locally or they're forced to trust someone. What this mechanism is going to change is they either build locally or they may trust someone, and actually would force them not to build locally, but that's a different discussion.
I do agree that there's like a moderately profound difference in those two things. I'm not saying the design necessarily provides that, but like the difference between those two things is important. And it's important because of that assumption. It's also important because like it then makes the market more potentially competitive and valuable. Like it makes entering the market, you don't need trust. You can use like the facility. Yes, there's a difference between like using.
You don't.
Yes, you
do. You do need
like
trust
as a builder.
now.
I could just.
No, you need trust. You need to trust the relays.
Yeah, but I mean, I guess if you're a little builder and you don't have enough to put up the collateral, like to be a staked builder, then you'd have to trust the builder relay anyway.
Right, but
Like I don't
relays are
think the
becoming
long tail
vertically
of little
integrated.
builders are good.
Relays are becoming vertically integrated, and the difference between the two is probably going to erode. So you're trusting builders at that point. In what seems like a convergence.
Yeah, I mean, I think I still agree with Francesco, which is that like there's three builders that are kind of relevant here, and if those three builders decide to sign zero bid and like have this kind of reverts to the exact same thing today, where I as a local validator have to either trust one of those three builders or build locally. Like, you know, there is this long tail of builders that like could do better than my local block, but it's just like not that different compared to the value that the like three big builders are gonna provide me.
Sure,
You know
but
what I mean?
these
So like
markets
the
will
cost of
change
altruism
over
might not.
years.
And also we should not neglect what clients do. The reason we have this adoption today of MEV Boost is because we support it in our own clients. This is not something that we may be forced to do, and someone that wants to do some off-chain work is going to have to fork clients.
Well, but they can already just use MEV Boost. Like that already exists. The off-chain software already exists. That's the point.
Yeah, and someone is going to have to keep those forks.
I do think over-indexing on the fact that there are three, or who those three are today, and designing the protocol around them, it helps enshrine them. It helps reduce the competitive of the market. It helps reduce like potential changes over time, by just assuming, oh, well, we have these actors, we can't do anything about it. It might not change anything immediately, and they might not use the facilities, but it does open the fact that the market can become more competitive, or at least shift.
Right, but at what cost? Which is like kind of my point. It's like if we do like we double the slot time, we add these new committees, we do all this stuff, and then what I'm hearing is we do all this to like maybe allow this like median segment of the market to to exist.
I mean, I think like the real argument here is that you need to have a low cost of entry so that when collusion occurs, a competitor can enter. Like, let's say they suddenly started colluding now, but everyone has set only these three builders as their relays. Well, now you're fucked because now you have a really high cost of entry for someone new. So they will control the prices and someone new can't really get in. So you need like to leave this door open so that when they start colluding, someone can, well, I mean, maybe before I wasn't competitive, but now that they all agree to only pay 0.01 ETH per block maximum, now I can be competitive and I can enter the market.
Oh, but you can always do this because of the P2P. The P2P network would always give a baseline of what is the minimum bid.
I'm talking your like,
yeah,
I'm arguing for an EPBS
yeah,
design.
No, I'm not arguing against you. I'm just saying that this already is there.
Yeah. Right. No, I agree. This would be the argument. Like the danger with the relay design is that the open relays will go away, which ensure like easy market entry, because they like aren't competitive, and then like the builders control the market. So I think that's the danger with the relay design, and that's something that even very imperfect EPBS design could ameliorate.
Okay, I'll just note we have a few minutes left for this call today. Yeah, next up. Well, I think it sounds like there are many next steps. So we'll probably want another breakout. A big thing was if we could figure out, or if we could like gain a clear understanding of, these fork choice details and like how big of an issue this builder safety thing really is. And like, at least for me, I think the takeaway from this call is like balancing all these different concerns. Cause like we were just, painting this picture where even sort of a suboptimal quote EPBS could actually do a lot of good if we're worried about relays disappearing and what that implies. So even if there's not like a, let's say perfect builder safety, it might still be worth the complexity. So yeah, I think that will ultimately be the deciding factor in this whole thing, is finding the balance there.
I'd love if somebody wanted to take on trying to write down the design criteria. Okay. Because then, I think we all have this like thing in our head, and we all would be getting to kind of hone in on what the design criteria. But yeah, I think just somebody attempting it, like Potas, yes, you'll be very biased. You have your own design criteria, but it's going to begin to then someone can say, oh no, but what about these two things? What about these? And we can like have a more principled
So what I'd
conversation.
like is to what are the things that we are set and we at least agree. It seems that we all agreed on what the definition of builder safety is, and we want that as a design condition. And I think we also agreed, I'm not sure, but I suspect that we also agree that we want to keep the slot time. I wonder what are the other designs that we might already have agreed upon. From today's meeting, I take that those two are a requirement. I think that the second one requires you to have a small committee for the second vote. For builder safety, I think we need to explore and solve that problem. But I think we can solve that problem.
Enrico?
Yeah, just a question about the slot time. So you're mentioning that could be pretty complex to change the slot time. And you said from a technical perspective, not only from a sessional perspective. So what are your arguments there for the slot timing to be
so
kind
the
of...
problem with slot time goes down everywhere. Like it affects tooling, it breaks existing things, it might break even contracts. There's contracts is very hardly that they're going to be broken. But the thing is that there's a lot of things that are downstream that depend on the slot.
So I mean outside
we have
the
things
consensus.
That are already
you mean outside outside the consensus?
Yes, outside of consensus. Even so, we already have contracts that check on timestamp, and that sort of like assume they have this thing which is timestamp to slot, which is currently a dictionary, and we're going to be breaking that. It's a very tough change to change the slot time. But on the other hand, on the bright side, I think EPBS brings us something that is great, which is the fact that we can go down. So the node currently does the critical validation all at the same time. On EPBS, you pipeline it much better. You have it, you can attest at 3 seconds because your block is much smaller and it's much faster to verify. And you can verify the payload at the time where the node, the consensus layer node, is doing nothing. So from the point of view of engineering and pipelining, EPBS is much better for our CPU, is much better usage of our CPU than it is today. So I think it's doable to do 12 seconds by shortening the attestation time. Which, by the way, also like shortening the attestation time gives less margin for that balancing attack.
Okay, we are at time, and people I think are streaming out. Yeah, so it sounds like an immediate next step is just having like a clear design doc we all agree to, and I think we can coordinate around that asynchronously. Does that sound good to everyone? Okay, got some thumbs up. Great. Okay, thanks everyone for coming, and I'll see you around the internet.
Thank you.
See ya.
Bye.
Thank you.
Bye, Alex.
Bye bye.
Thank you. Bye.